it once again. Alpha's first, in reverse. You said let's go to where it lies. But Phoebe, you know how much you hate catching trains, and you never wanted to go back there again. Get homesick before you've even closed the door. Well, that's the Phoebe I know. Please make sense, at least this once. You've never liked the cold. Put down your case, close the drawer, and leave your clothes upon the floor. But baby, you know how much you hate catching trains, and you never wanted to go back there.
So I'm getting about 87 milliseconds. Oh, I had a dream last night.
Tell me about your dream.
It was like the edge of the ocean, and there was a sofa.
The edge of the ocean and a sofa.
Yeah, there was a sofa with some kind of flowers heaped on it.
Okay.
Growing or heaped. I think tulips.
Uh-huh.
And green tulips. And then I looked at the surf.
Yeah.
And there was like an eye.
Yeah. An eye? Like a human eye?
Yeah, or the eye of a scallop.
Eye of this, like an eyeball?
Yeah, sort of, just like an eye.
Okay.
But it was huge.
In the surf?
Yeah, well, this reminded me of it when I was looking at this.
Oh, okay.
Yeah, just like, it was huge.
Strange dream.
Yeah, I wanted to tweet about it later, but I didn't know what to say exactly. Anyway, something will come up.
Something will come to you.
Now, let me see. Here's the mirror thing. Good. We'll go back up into the... Oh, great. Now we're trapped over in this stuff. Let's see if we can get tunnel back inside. Okay, good. Slow down. Good. I'm looking down the tunnel. Down the tunnel, and 180 degrees. We see that. That's an excellent place to put that. Good. So, a mirror with a color pattern on it. So, great. So now we're looking down the tunnel of the spheres, the sphere arches, and we're getting 76 to 75 milliseconds. And we're looking into the same thing but in a mirror. Don't worry about that artifact in the center, that bullseye. That's not correct. And don't worry about the color as it's coming out in the mirror. Just know that it's a mirror. It is shooting rays into the scene and picking up the spheres, even if it's shading them an odd dark gray. 87 milliseconds. So 88, 84. So it's only losing like, it's only adding like 10 or 15 milliseconds for the mirror bounce. Of course it, yeah. So that's pretty nice. Now, even though we're already tiny here, I'm going to go even tinier. And go. Shoot. A mirror to this wall. Make a line of mirrors to that wall. So this is not fast, but there's a reason. So every ray here essentially is going through many steps, because traversing the interior of one of these spheres means traversing a space that's been subdivided many times in order to accommodate this complicated sphere that's been drawn. So observing the sphere from the outside doesn't take many steps, but traversing the inside of it does. But you know, with the 80 cores, this would be 6 milliseconds. So, and 80 cores will come. Due to the parallelizability of what we're working with here, the speed of the cores doesn't matter as long as you have enough of them. Oh well, that little trap means we're done. So let's think of something else to do. Okay, so that sphere, though, I wonder, is it based on 2 space or 3 space? Let's see. So go to Marsh. I believe that's shot. There's Zot 2. So let me just fire her up again. I'll make it a little faster and smaller. Well, it doesn't really have to be faster. Fire it up again. So the question is, am I using M2 space or M3 space for the spheres? And if I'm using M3 space, is M2 space going to be faster? So the first thing to do is figure out exactly what object I'm using to make those sphere arches that we were looking at. So there were in here ways. So after this, there were that. Right. N2Q, okay. N2Q667. Alright, we can stop that. So I want to search on N2Q star 7. Look for this module. Red dot, so I'm already using M2 space. Right. Okay. So let's use M3 space and see if it's slower. Right. Right. That means nothing. It's just a... I have no idea why it happens, but it isn't a fatal problem. I don't have to bring down the system and reboot it. Oh, I see. Oh, I have no idea what I just did, so... Oh, I see what happened. Okay, I see what happened. A simple misunderstanding. That was my error. I'll start again. I'll come in again. No one expects Spanish Inquisition. Our main weapons are fear, surprise, a fanatical devotion to the Pope, okay. So let's replicate pretty much what we had before. So 5, get smaller, and we want 5. I believe 5 takes us to that, 6 takes us to that, 7, and I believe we're looking for, right, and we want much smaller, and that. Oh, I see. Oh, I can't go into that stuff anymore. Or can I? That's interesting. That green grass, I'm like excluded from the voxel that contains it, I think. Which I wasn't. I don't remember having. Well, it doesn't matter. Okay, so we wanted to create a tunnel of these. then we look down the tunnel and we see what kind of frame rates we get. And we appear to get better frame rates using an object with a division of space based on powers of 3 than one based on powers of 2. And you know, that's a weird thing, because in computer science you generally think powers of 2 are more efficient than powers of 3 for these sorts of things. But it has to do with the interaction between, you know, memory access, and it's quite subtle actually, and the way the object is built. That's interesting. So you see why I do play with powers of 3 as well as powers of 2. I mean, there are reasons besides the obvious one, which is that you need powers of 3 space to make a Sierpinski cube. But it has to do with the way the rays count through space and the way these objects are drawn and the way my objects are laid out in memory, which here's a mirror thing again. And we notice a general stuff is getting drawn everywhere, because obviously every time I draw the sphere it's an instance of an object which is never made unique, which is not the way that. So if I draw into this one, I'm drawing into everyone. Which is, you know, nice for some things, but not the way you want to build a world. And that's actually a programming problem I'll have to work on soon, because obviously my copy on stroke is not working with my new MSpace shader. I don't know when that stopped working, sometime in the last couple of years. This is nice. This is nice. Nice. Way better than 2-space. Maybe 4-space would give me even better performance, but the problem is you start using more and more memory. As you go to higher energies of space, spatial division. I mean, it's possible. I can heck, let's do it, you know. For instance, and then, so let's just get the divisible 3-space here and just make a version of it with the arity of, say, 5, and see how fast that is. So this space is going to divide into, one voxel is going to divide into 5 by 5 by 5 voxels. So that's 125 subvoxels. That means that that there's 125. That's a lot of memory for. Okay, no. Okay. So let's search for the string nm3 and replace with string nm5 in all occurrences in this file. The constant will change from 3 to 5, and I believe that's all we have to do, except change up and just make this basically an empty procedure which has no application. Okay. So and what was that? N2 Q star 667. Now, this is something interesting. So normally in Oberon, you import modules that you're going to use. And what I just did here doesn't require that I use importation. So I have a new module, nm5, and I'm using it by instantiating it here. Red dot is equal to base dot voxel from name nm5. So I'm using the module, but just using the name of the module. That's why these names are in general they look like these meaningless hashes. Because these names are never used for importation, they're just used as strings. And I often derive them by hashing. Ideally, they're automatically derived by hashing the source code, so that, in fact, if you make a one-character source modification, string modification, if you change one character in a file, then the name of the file changes too, because it's a hash. It's done automatically. That's the idea. But anyway, so the point is that I have a module nm5 now, which another module is using just from the name of the module. It's not importing it. This is actually very important, because what it means is that eventually in the blocks voxel world, you should be able to program it from within itself. You should be able to look at the code that's producing a certain voxel, clone a voxel, look at the code, change the code, instantiate it or res it as a new voxel, and do this all in world. And that's the idea. Anyway, so let's see how fast our new nm5 space works. We're going to do essentially the same thing. Make the same tunnel, go 4 sizes down, find that weird it's not clear, exactly, because the shapes of things are different in different spaces. Let's see, 1, 2, 3, 4. Okay, 1, 1, 2, 3, 4, 5, 6, 7 was it? 8. Okay. For ease of use, we're just going to go down. So that's now 5 space. It looks a little different. 63 milliseconds. So this is not faster than the 3 space anymore. 52 milliseconds. This is not like any faster. Oh, I see, but since it's still doing it at size 16, we're doing it right. It's like limited. Okay. Yeah, it's not clear that this is a fair way of testing them against each other, actually, because still, you know, I like that cross that shows up. In the limb of the arch, or in the limb of the window. I like that, like fenestration or morion or whatever you call it. So let's just see, let's keep that. We'll keep the 5 space, and I will show you what a very smooth, see how much slower it gets. Okay. In case we crash, we're going to save the desktop so these files will be available if we have a crash or have to reboot for any reason. But red dot F raster ball 16. So that number 16. So obviously 25 is a power of 5. Let's pick 125. Nice power. 125. Nice power of 5. This will be very small block. So we're going to make the sphere out of a 125 by 125 by 125 block. But we're not going to create all the subdivisions in empty space. We're just going to create the ones necessary to create the... I'm sure we've all seen a grid. Like you know, a multi-resolution grid. I think we know what we're talking about. Okay. Alright. And action. It's not going. Okay, there we go. Yes, meaningless trap. That doesn't mean we can't try again. Okay. Bio break.
I watched you spin the globe, and when it stopped, you spun it once again, half as fast, in reverse. You said let's go to where it lies. But Phoebe, you know how much you hate catching trains, and you never wanted to go back there again. You're homesick before you've even closed the door. Well, it's the Phoebe I know. Please make sense, at least this once. You've never liked the cold. Put down your case, close the drawer, and leave your clothes upon the floor. But Phoebe, you know how much you hate catching trains, and you never wanted to go back there again. You're homesick before you've even closed the door. Well, it's a Phoebe I know. Forever together, you stay in my heart. You know that I will love you. Together forever, you know every part that I will think of you. Together forever, you'll stay in my heart. You know that I will love you, but you'll always mean heartache to me. I watched you spin the globe, and when it stopped, you spun it once again, half as fast, in reverse. You said let's go to where it lies. But Phoebe, you know how much you hate catching trains, and you never wanted to go back there again. You're homesick before you've even closed the door. Well, it's the Phoebe I know. Please make sense, at least this once. You've never liked the cold.
Oh, please.
Put down your
Open
case,
type.
close the drawer, and leave your clothes upon the floor. But Phoebe, you know how much you hate catching trains, and you never wanted to go back there again. Yeah.
Didn't change anything that should lead it to crash when open. And in fact, it does not. Oh, 333, okay. Ooh, 1, 2, 3, 4, 5, 6, 7, 8. Alright, now. Oh, here we have now you finally see the purpose of that weird bullseye. The bullseye improves the resolution. Its resolution is better within it, and the bullseye, the radius of the bullseye is controlled by the frame rate, because there's a target frame rate. However, 9999. What we wanted was so you see that these ever so smoother five space spheres aren't really much less. Again, see the there you can see the fovea or bullseye. Fovea is a better word. You can see the fovea much better. You can see what it's doing. See the sphere. You see how the resolution of the sphere, it actually is poking. Actually gotta get one of those. I want to try one of those, an AMD chip. I want to try like an AMD thread killer. I'm not sure it would be worth it to get one of these 16 core babies though. I think maybe I should hold out for the 32 core server chips, dual CPU motherboard, 64 core, 128 thread. I wonder how much a workstation based on those costs. I'm not sure they're out yet, so I haven't priced them. Okay, I'm liking this 5-space. Okay, so you see the speed on that. So we're going to try to do something comparable, but we're going to go back to 3-space. Okay, so we're going to go back to 3-space, which means change this from NM5 to NM3, and since it's 3-space, we'll just drop down from 125 to 81. If we could leave it at 125 and it would just hit 81 anyway, since anything between 81 and less than 243 would just cash out at 81. But I like to leave it neat, tie it up, wrap with a bow, get it exact. Okay, so we'll just go right back and try to do the same thing and get a sense of whether the so this sort of, going back and forth and experimenting and like just what looks good, what doesn't, like, working on the code, flying around, looking at stuff. Like, this is how I spent the last, 12 years. Like, when I've been feeling well enough. So when I've like not been out on walks or like having migraines or whatever else it was that I was doing. But in terms of my, professional intellectual work, this is pretty much what I've been doing. Good work if you can get it. 1, 2, 3, 4, 5, 6, 7, 8. Yes. 1, 2, 3, 4. Okay. So it's like it's just annoying to try to get inside them. So looking at the speeds, I mean, there's no clear yeah. So the 5-space is in no way clearly superior. And we know the 3-space is like less memory intensive. So, and yet the 3-space does seem to be better in some ways than the 2-space, and necessary for some things. So I like the 3-space the best. Now, line, this little exercise here, what it mostly shows is how good the space is and just how easy it is to draw into this space. So I'm just drawing lines of occluding spheres, and each sphere being made up of, thousands of tiny cubes. And if we draw into one of these little spheres and modify one of the cubes, it will do the same thing to each of them, but that's actually an error that I should fix. I mean, it wasn't that way before and it won't be that way soon. Because they should all be identical, pointers to the same thing, except that when you modify one, make a hole in one, it shouldn't modify the others because it should create a copy at that moment. Copy on stroke. So we see there's a crudeness. And we see that if we had better resolution, if we had more rays, it would be better. But it's still very pretty. It's much easier to navigate if you don't have the camera too flat. If you have this some fisheye, it's much easier to find you. Ah, there's the sky. There's a sky at the edge of the world. Beyond the sky, of course, the world just wraps. You see it wrapped there. I think we're on the other side of the sky. Yes, we crossed the sky. I mean, obviously this is already well beyond what you would need to make a fun and interesting game. But it does not. It's not yet at the point when it will subsume. It's not yet at the point when it's clearly better than GPUs for general purpose real-time stuff. It's very close. Of course, the thing that will come last is, I mean, there'll still be the question, how do you do fast animation? How do you do this? How do you do that effect? And of course, I can't do all that myself. But in terms of getting the basic thing fast enough, that will just happen. I mean, that will happen automatically. And in fact, I had already accomplished the software side of that, you know, whenever I parallelized this thing, which was, I don't know, like 2006 or whatever. What is nice is, I think Oberon will get some more exposure. I mean, there's basically one guy working on the compiler for Active Oberon now, Felix Frederick at ETHZ, and he's doing some good work. At some point, he has internally a 64-bit system, but he hasn't released it for Linux. So I'm really eager to try it, even though I know it'll be so much slower. This is a 32-bit system. OS. Anyway, I'm not sure how. I mean, obviously you could use some of this. You could use these algorithms on another operating system. I'm not sure how easy it'd be to do the parallelism. I mean, I have looked. I mean, other languages have disadvantages, you know? Like, if you want, I mean, because you want hardware speed, almost equivalent to or almost equivalent to what people call C, you know, C level. But you also want I mean, obviously this could be written in C. I mean, I couldn't have written it in C. Maybe I could now, but I certainly couldn't have when I developed it. And what's more, nobody else could have thought of it and written it in C. And my proof for that is an existence proof. Namely, nobody did. Somebody could have, I presumably would have. I just love that, the geometry. It's so rich in geometry, the world you can make here. And I'm not even using the whole big small thing. I mean, I was so impressed with Minecraft when I first saw it. I didn't understand how it was doing, like, that it was doing the surface extraction. I had already developed my stuff, mostly, And I just didn't understand how a GPU renderer could do that blocks world. Of course, it does it with surface extraction, and of course there are things that a Minecraft style renderer can't do that I can do. But well, for instance, you never see a Minecraft style renderer. You never see a Minecraft style world with different sized blocks and different sized holes. Whereas it's trivial easy for me. I mean, imagine what you could do with this if you had like dozens of people hacking on it on GitHub. You know, just imagine what you could do with it. For instance, even to add Minecraft style lighting, and Minecraft lighting is about as basic as lighting gets. With the propagation, that would be so much fun. I haven't gotten to it. And to add path tracing stuff, radiosity, like cellular automaton lighting. I've been out of combat for a few years, so I haven't done very much. I think I'll be able to do more now, but I won't be able to do everything. But it would be so much fun if I had other people to code with, GitHub. I mean, it's on GitHub. It could code with other people, but where are they? Well, I have no idea where I am. I'm inside something. Well, so much for that. I think I'll close the stream down. I should go rotate and do something else. Anyway, alright. Please like, subscribe, leave comments. If you want to join the raffle, leave Bitcoin. The Bitcoin address is in the stream description, and send it to the raffle address. And like, subscribe, and thanks for watching. And maybe I'll select you in the show chat next time, and we'll have a guest chat.